7.2, Anti-Differentiation by substitution. So we're finding the indefinite integral. This means you have to know what you're doing because you can't just put it in your calculator and mint it, numerical integration, or just math 9, whatever that works out to. For this one, we add 1 and then divide by that, which gets us to this, and then put a plus c. So we get -1 over x plus c. This is just straight up arctangent. Watch your variables. You should be correct with your variables. As a horrible tendency to just kind of slap something up there and be like, that's close enough, which is not good. 3x to the 5th over 5. Add 1, you get -2, divide by that. So plus x to the -2, which I'm going to leave there. I'd usually go with 1 over x squared. I'm just going to leave it. Plus tangent of x gets me secant squared plus c. This is just 2e to the x plus secant x. Now we have x to the 1/2. We add 1, get 3/2, divide by 3/2. It's like multiplying by 2/3. So that's -2/3 x to the 3/2. Please check that always. 2e to the x, done. Secant, yeah. 3/2, cancel, 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 cancel. X to the 1/2. We get there. Always double check. Now, this is what I just said. Use differentiation to verify the anti-differentiation formula, meaning that if I go ddx of 1 over L n of 5 to the x plus c, I get, c is going to zero out. E to the x is just e to the x. 5 to the x is just 5 to the x times ln of 5. So we get ln of 5 over ln of 5 to the x, which is what's inside the integral problem. So over here, ddx of arc sine of u plus c, derivative of c's combined, is 1 over square root of 1 minus u squared. Did I really have that memorized? No, of course not. I just figured that had to be it if I'm verifying the formula. So, piece of cake. Verify that integral f of u does not equal integral f of u dx. So the integral of u squared du is u to the 3rd over 3, done, or since we know that, x to the 15th over 3. This should not equal integral of f of u dx. So integral of u squared dx, well, I can't do that. Integral of x to the 10th dx, plus c, naughty me, plus c, equals x to the 11th over 11 plus c. Yeah. And over here, integral of sine of u du equals negative cosine of u plus c. Yeah. And that also equals negative cosine of 4x plus c. You're probably screaming, what about chain rule? We're not taking derivative, we're taking an integral. So we don't have to worry about that. Integral of sine of u dx equals integral of sine of 4x dx, which is negative cosine of 4x over 4, because of chain rule, plus c. Check by going backwards. Make sure you understand what just happened. And notice these do not equal. Use the indicated substitution so they're making your life a little bit easier. So I'm going to go right here with du equals 4x dx. Du over 4x equals dx. Integral of x cosine u du over 4x. Integral of cosine of u is sine of u plus c, which you can't stop at. Before we did, but or could have, but we didn't. You know what the u is, so we have to finish it off. I like putting the 4 on the bottom just because that's just what I do. And then plus c. Take the derivative if you don't believe me. Du equals 7 dx. It's a weird little problem. Du over 7 equals dx. Integral 28 u to the third du over 7, 1/7. Things didn't really cancel here like we're used to. 4 out front, u to the fourth over 4 plus c equals 7x minus 2 to the fourth. There's nothing on the bottom, so I'll just pretend that was part of my underline of the problem. That's it. Du equals -3r squared dr. Du over -3r squared equals dr. Integral, I like to put the 9 out front. R squared just sitting there. Square roots, and I can't work with a square root, so I'll go to the 1/2, which I'm going to have to fix in a minute. 1 minus r3 u times du in -3r squared. Gonna make that -3. R squareds cancel. Still have integral of u to the -1/2 du. Add 1, it's 1/2. Divide 1/2, it's like multiplying by 2. -6 u to the 1/2 plus c, which equals -6, 1 minus r to the third to the 1/2 plus c. Probably should have rewritten this as square root, but I'm not gonna. Du equals 4y to the third plus 8y dy. Du over 4y to the third plus 8y equals dy. 8 out front. That's my u times y to the third plus 2y times dy. I'm going to factor out a 4 here, and I'm going to rewrite it right below it. Dy over 4 y to the third plus 2y equals dy. 4 I like to put a little thing there to divide up my problems if I ever get confused. Really should do it over here. 4y to the third plus 2y. Two u to the third over 3 plus c. 2 y to the fourth plus 4y squared plus 1 to the third over 3 plus C. Yep. And now they finally put us on our own to figure out what we're doing here. This equals 3 integral of, well, sine x to the negative second is sine x to the bottom. It's just the same as cosecant squared x dx, which is negative, 3 just comes along the ride, cotangent of x plus c. All right, derivative of cotangent, negative cosecant, 3. Yeah, we're good. This looks like derivative of cotangent is cosecant. So u equals cotangent of x, du equals negative cosecant squared x dx. Dx equals du over negative cosecant squared x equals integral of u to the 1/2 cosecant squared x times du over negative cosecant squared x, goodbye, negative out front, equals negative u to the 3/2 divided by 3/2 times 2/3 plus c equals negative 2/3 cotangent of x to the 3/2 plus c. Off we go with all the problems you have to practice. Without doing these, you have no chance. U equals tangent of x over 2. Du equals 1/2 secant squared x dx. 2 du over secant squared x equals dx. Integral of u to the 7th secant squared x over 2. Naughty me. I remember chain rule, but I remember to write that in the first place. Times dx over 2. Cancel out front. Secant squared x over 2. Goodbye. Integrate. That's not dx. It is dx. It's not x, it's u. U to the 8th over 8. 2 over 8. U to the 8th plus c equals tangent of x over 2 to the 8th over 4 plus c. Equals integral of cosecant squared 3x dx. Doing this one a lot. Don't have to do substitution. You could just divide out 3 and check. I think that's how it's going to work out. But a lot of people get the warm fuzzies from this, so happy to do it. Equals cosecant squared u du over 3 equals 1/3 negative cotangent of u plus c equals negative cotangent of 3x over 3 plus c. Derivative of sine is cosine, but derivative of cosine is sine. My experience is that it's always on the bottom. Plus, when you have a 2 plus, you know that that's going to vanish. So u equals 2 plus sine t, du equals cosine of t dt, dt equals du over cosine of t. Integral 6 cosine of t u squared times du over cosine of t. I just took a second to check my negatives there. Equals 6 integral u to the negative second du. Add 1, negative 1, divide by that, equals negative 6 u to the negative first plus c equals negative 6 over 2 plus sine of t plus c. Derivative of secant is secant tangent. Derivative of tangent is secant squared. This one's going to work either way. I like the idea of getting rid of the secant squared, but no, it wouldn't work either way. Well, I might. I don't know. I have to play with it. U equals tangent of x. Du equals secant squared x dx. Du over squared x equals dx. Integral of u squared secant squared x equals u to the third over 3 plus c equals tangent of x, tangent cubed x over 3 plus c. Alrighty. A lot of people see this and scream arctangent, arctangent. Well, there's still an x on top, so watch out for us tricky teachers, calculus teachers, evil calculus teachers. I could go on. Over 2x equals integral x u du over 2x equals 1/2 u to the negative first du. Shouldn't have done that. Equals 1/2 ln of absolute value of u plus c equals 1/2 ln x squared plus 1 plus c equals 1/2 ln x squared plus 1 plus c, because no matter what I put in there, I can never get 0 or a negative number. But this, of course, is fine too. So this is a pretty tough problem. I see it on a regular basis. I don't know how to describe this except that I have it memorized. You have to go u equals x over 5. I'm going to try and do this one in class. Du equals 1/5 dx. Dx equals 5 du. So put the 40 out front. Now this is where things are going to get weird. 5u equals x. So x gets replaced with 25u. U squared plus 25. And dx is 5 du. So this equals 40. Holding off on the 5, you'll see why in a second. 5 over 25 u squared plus 1 times du. 5, 8 equals 8 integral du over u squared plus 1 equals 8 arc tangent u plus c equals 8 arc tangent x over 5 plus c. Yeah, that's pretty hard. No, I don't have a good way for students to think about that. So good luck. Hope you can figure that out. This is integral of tangent of 3x dx. I guess we go u equals 3x. No, we do better than that. Equals integral of sine of 3x over cosine of 3x dx. U equals cosine of 3x du equals -3 sine of 3x dx. Du over -3 sine of 3x equals dx equals sine of 3x cosine of 3x du over -3 sine of 3x. Cancel, cancel. -1/3 equals, I don't know why I wrote cosine, that's u. -1/3 integral 1 over u du, which is -1/3 ln of u. I'm going to sub in because I'm running a little bit out of space here. I don't know why this is 33. It's 3x. Cosine of 3x plus c. Definitely need vertical lines because cosine can go up and below negative. We can't have that. Last but not least, on this page, u equals 5x plus 8, du equals 5 dx, du over 5 equals dx. Equals the integral of, that's my u, so it's u to the -1/2 du over 5 equals 1/5 u to the 1/2 divided by 1/2 is times 2 plus c equals 2/5 5x plus 8 to the 1/2 plus c. Really should make this a square root, but I'm lazy. Onwards. Use a given trig identity. So this is kind of Calc 3 stuff in a lot of ways. Yeah, I'll just leave it at that. So use a given trig and set up a u substitution. So it doesn't say to use that. Knowing that secant equals 1 plus tangent squared x, we can say that this equals secant squared. We'll leave a secant squared of x, 1 plus tangent squared x dx. Derivative of tangent is this, so let's try u equals, now I can't make a tangent squared because that'll cause problems. Let's try u equals tangent of x. The derivative of that is secant squared, and they'll cancel. Du equals secant squared dx. Dx equals du over secant squared x equals integral secant squared x 1 plus u squared du over secant squared x equals, now we get to integrate, u plus u to the 3rd over 3 plus c equals tangent of x plus tangent to the 3rd of x over 3 plus c. That's what I call working for a living. All right, now we get this weird little substitution here. Cosine of 2x equals 2 cosine squared x minus 1. Well, I would rewrite that as cosine of 2x plus 1 equals 2 cosine squared x. And then, yeah, I can do this. U equals 2x. 2 cosine squared x. So this is equal to integral of 2 times 2 cosine squared x. There it is. Cosine of 2x plus 1. I don't need u substitution at this point, but I'll do it anyway. U equals 2x, du equals 2 dx, dx equals du over 2, equals integral of 2. Why do I have a plus 1 here? So weird. Don't need an extra parentheses. Cosine of u plus 1. Put this out front. Oops. Now I have to replace this. Du over 2. See ya. Equals sine of u plus c equals sine of 2x plus 2x plus c. All right. Cosine squared minus sine of x. I can factor this. Integral of cosine squared x plus sine squared x, cosine squared x minus sine squared x. I happen to know that this is 1. And I can just replace this. Cosine of 2x dx. U equals 2x, du equals 2 dx, du over 2 equals dx. Integral cosine of u dx over 2 equals 1/2 sine of u plus c equals 1/2 sine of 2x plus c. That's it. And then we get some definite integrals. I'm going to go with u equals 1 minus r squared, du equals negative 2r dr, du over negative 2r equals dr. That was weird. U of 1 equals 1 minus 1, 0. U of 0 equals 1. Integral 1 to 0. I'll have to fix that in a minute. R u to the 1/2 du over negative 2r. Get rid of the negative and flip this upside down. Equals u to the 3/2 divided by 3/2, like times 2/3. 1/3 u to the 3/2 plus c. Whoa! What happens when you don't turn your brain on? 0 to 1 equals 1/3. I'm not going to put it, I'll do it for you. 1 minus 0. Whew, I call it working for a living. U equals 4 plus r squared. Du equals 2r dr. Du over 2r equals dr. U of -1 equals 5. U of 1 equals 5. This problem just got really, really easy. Integral 5 to 5. 5r over u squared times the u over 2r. I'm not moving the 2 because we're done. Gotta like it when math works out once in a while, huh? Keep going. U equals 4 plus 3 sine of x. Du equals 3 cosine of x. Dx equals du over 3 cosine of x. U of negative pi equals 0, 4. And we get another 0 coming up because u of pi also equals 4. So this changes to 4 cosine of x over u to the 1/2 times du over 3 cosine of x equals 0. Nice. Let's see. I'm going to go with u equals cosine of 2 theta, I believe. Du equals -2 sine of 2 theta. d theta equals du over -2 sine of 2 theta. U of 0 equals cosine of 0, 1. U of pi over 6 equals cosine of pi over 3, 1/2. Boy, I don't trust that. Pi over 6 times 2 is pi over 3. Yeah, that's right. Integral 1 to 1/2, which is backwards, so we'll get rid of our negative in a minute. U to the -3rd sine of 2 theta. Du over -2 sine of 2 theta. See ya. -1/2 equals 1/2. Flip the integrals. 1/2 to 1. U to the -3rd du equals 1/2. Add 1, -2 divided by -2. U to the -2nd. 1/2 to 1. -1/4. 1 minus 1/2 squared is 1/4. 1 over 1/4 is 4. Equals 3/4. Wow. This one I can do without substitution, but I won't. It's just going to be natural log of 2x minus 3 over 2. I have to change those, but one step at a time. 2x minus 3 du equals 2 dx. Dx equals du over 2. U of 2 equals 1. U of 5 equals 7. Integral 1 to 7. 1 over u du over 2. 1/2 natural log u, 1 to 7. 1/2 natural log of, you can put parentheses now because it's positive, minus natural log of 1, 0, equals natural log of 7 over 2. No, I'm not putting that in decimal form. Cotangent of x is integral from pi over 4 to 3 pi over 4 of cosine of x, sine of x dx, which means I have to go, I don't know why I did that, u equals sine of x du equals cosine of x dx equals du over cosine of x. U of pi over 4 is root 2 over 2. U of 3 pi over 4 is root 2 over 2. Done. Root 2 over 2. Root 2 over 2. Cosine of x over u times du over cosine of x, 0. This is one of my favorite ones, the e's. I just think they work out neat. It's not like it's an easy problem or anything. U equals 3 plus e to the x, du equals e to the x dx, du over e to the x equals dx, u of 0 equals 3 plus 1 is 4, u of 2 equals 3 plus e squared. Integral 4 to 3 plus e squared, e to the x over u times du over e to the x equals ln of u, 4 to the 3 plus e squared, equals ln of 3 plus e squared minus ln of 4. Can I keep going on that? I could make these divided. Done. Equals ln of 3 plus e squared over 4. Hey, isn't there a way to get that e out with an ln? Maybe, but I ain't bothering. I sure hope you did these problems, boys and girls. This is really challenging stuff. You tried to blow it off. Good luck with that. Good luck and happy mathing.